we are going to solve Leetcode easy level question 257 binary tree paths. Let's get to the question. Given the root of a binary tree, return all root to leaf paths in any order. A leaf is a node with no children. Okay. Here is the tree they have given. We will be getting values 1, 2, 3, null and 5. Okay, and we have to return a output which will be going to all the roots, like root to leaf paths. Okay, so what is root to leaf paths? So this is a root to leaf path. So 1, 2, 5, and then 1 and 3. So yeah, these two are the possible root to leaf paths. Similarly, if suppose there will be 4 here, then it will be 1, 2, 4, 1, 2, 5, 1, 3. Okay. So, okay, let's solve this question. We will be solving this question in a method or in a way how we gonna solve it during our interviews. That's how you should be projecting yourself in the interview. If an interviewer will be going to ask the question. Okay, so let's do it. So here we can see that we have to return our answer in the form of list string. Okay, so if we have to return our answer in the form of list string, let's just make a array list, because at the end we have to keep adding the paths. We cannot create a array, so it will be undefined length of it will be of undefined length. So we will create a array list. So now just let me create array list quickly. It will be a string type array list, because we can see the path is getting stored in a format of string with that arrow also. We will be adding that too. And so array list, we can call it result is equals to new array list. Yeah, so this is the array list. Okay, now let's move ahead. What we have to do? So let's just write a simple base condition. So if root is equals to null, then what should we return? In the interview, you should be asking the interviewer, suppose the root is null and there is no node, then what we should return? We should return something else, or -1 or null. So for now, I will be returning null. Okay, root is equals to null. Then we will simply return null. And another base condition which can be, suppose there is only one path, means there is only one node, this one, then we should return this too. Okay, just the one. So for that, what we can do is we can create the string. So to create that current path string, so we are gonna create current path string. Okay, so just let's give it a string current path. Yeah, so what it should be, it should be this integer. This will be an integer value. See, this is an integer value in our tree definition. In our tree class definition they have given us, so we have to convert this integer into the string. So for that we will use the integer dot to string inbuilt function, and we will just give root, sorry, root dot val. Okay, so this will convert our this this integer value of this node into the string. So it will be, for initial, it will be just like this one. Okay, now only suppose only one node is there in tree. Okay, so what you will do then, we will just first check whether like we have the root dot left, like we have the left subtree. uh, so if we don't have the left subtree, and root dot right is equals to null again. So if we don't have the left and right subtree, then what we will do? Remember, first we have to add. So see, when we find a path, so 1, 2, 5, we found one path. We are adding that path into our result. Okay, into our result we are adding the path. Similarly, when you find the first path, you should add it in the result, because after that there is nothing. There is no node. So that's the single thing. So yeah, that's what we will just do, result dot add, and here we will add that path. So what will be the path? Current underscore path. Okay. So we will return the path, and yeah, for sure we just have to do return result. So in this case we will be returning our string also, and that's the whole. This will be the answer. This is the answer. Okay. Okay. Now in any other case we have to do some functionalities. We will look to it. But the thing is, returning result will be same. How? At the end, whatever you do, you have to return this result. So we will just do return result. Okay. Now let's think about how we will solve it, like the main logic. These are like boilerplate base conditions. Now the main part comes how we will approach it. So see, if we want to get the path till the root, like from the root to the leaf, if we want to get the path, what we are doing? We are traversing from each node. So see, first we hitted one. Okay, that's how we already stored one in our current path. Then we hit it 2. So then if we hit 2, then we will store like this. We will store like 2. And then we will hit 5. And then we will hit 5. And after hitting 5, we will be getting to know there is no left and there is no right. Okay. There is no left and there is no right subtrees, or left node and right node. There is no left node and right node. So at that point we will know this is the leaf node, and that will be the our final path, and we will add that path in our current path. Okay. So how it's gonna work? I will do the dry run again. Don't worry. First, we have to traverse. So obviously we have to traverse. Traverse what? Traverse left. Similarly, we will do traverse right. Okay, traverse left and traverse right. Now, suppose we have a function traverse. Okay, traverse, and in this we have to traverse left. So for traversing left, what we will pass? Root dot left we will pass, and we should also pass current path, so that the path should be keep getting updated. Okay. Similarly, we will have traverse right, here traverse right and the current path. Okay. Now the thing is, I'm not passing result. So what we can do is we can make this result global scope instead of just to this function. It will then again and again we have to pass that result in the parameter. Little bit headache. So just like place it here, and we can just leave it. Yeah. So this will be the answer storing thing. Okay, answer storing thing. Okay, now we did this. Okay, so now we will form the logic, or you can say we will create this traverse function. Very simple. Again, we will create a private. You can create public, but Leetcode doesn't support. Okay, so private traverse, and what we are sending? We are sending a tree node, which is let's just name it node for now. We are getting a string which is our current path. That's what these two things we are getting. Okay, now let's do the first thing. Suppose I'm here, I traversed right, and if it is null, there is nothing, then it will return us the null. It should return us the null, and it will come back to this part. So for that, what I will write, if not root node equals to null, again base condition, then what we have to do? We have to just do return. Okay, so see, this function has no type. It will return nothing. It's just a it's just like a it will function. It will not do anything, because at the end we are updating our result and we are returning it. So it doesn't matter what you return here. We don't need that functionality. So first we wrote this base base null condition. Okay, condition. Okay, first thing is the base null condition. Now what I think is, now I have to traverse. So yeah, I wrote here is like root dot left. So basically from here I came here. So what I can see is in my 1, when I reach 2, I should add 2 in the path. 1 I already added, now I should add 2 in the path. So here we say updating the path. So now updating the current path. Okay. So how we should do it? Current underscore path plus equals to, what we have to add is, first thing we have to add this arrow, then we have to append, what we have to append this node dot val. So by doing this we will be getting the value of the node also. So in this stage it will be like excuse me, 1 and then this arrow and this 2 and so on and so on, it will keep going. Okay. We got this. So now we updated our path also. Now what we have to do? Now we have to check whether it is a leaf node or not. Again, same thing. So now we will check again, like if node dot left is equals to null, and if node dot right is equals to null, then we have to do something. Okay, we know we have to do something now. Checking if the current node is leaf or not. Okay, so if it is a leaf, then what we have to do is, again, if it is a leaf, I told you, if it is a leaf, then we have to add this current path which we formed till now. So what we will do, we will just do result dot add what, current underscore path. After doing this, we will just do simple return. Like, this function doesn't have to do anything, it should go above, and when it will go above, it will see whether right is available, or if right is also done, it will go above. Like this recursion works. So this is the condition in which we are checking whether it's a leaf node or not. After checking that, what we can do is, now suppose this is not running. If this will not run, then obviously we have to traverse again, traverse right and traverse left. Oh, okay, that we know, we have to traverse again. So let's just write it, traverse node dot left with what, current path, obviously. So basically, see, we stored this path, it will traverse with this updated part to the left part, it will traverse with this updated part to the right part. So 5 1 will have like this, 1 arrow, 2 arrow, 5, and that's all. So maybe here it will end if it is, there is nothing after it. Okay, so and then you have to do traverse right also. Yeah, let me just copy it and quickly write it, traverse right, and that's the code basically. Let's see whether it will work or not. We will just run it. I hope so, it should work, and if we will encounter any error, we will solve it, no issue. So yeah, it worked perfectly. Yep, we got the answer. So let me explain it very quickly once. We will wrap it very quickly. So we first checked whether the root is null. If the root is null, obviously we have nothing, no option, we will return null. Okay. Then what we thought is, we can store this whole answer in a array list, because the length of the array is not defined. It can be anything. Okay. As many leaves we have, that many length we will have. So number of leaf nodes is equal to the length of paths, length of this array, result array. Okay, so here we had 2 leaf nodes, that's why the result array had the length 2. Okay, so now we created a array list here. We created it globally, you can say, in the class definition, so that we don't have to pass them again and again in the parameters. So once we done that, what we did was we created a base current path. So obviously, if we have only single node, the base current path will be 1, and that will be our answer. But if we have multiple nodes, we will keep updating this base current path and we will keep moving forward. So we created a base current path. and then we created if root is null and right is null. That's the thing. That's the only node in the tree. Then what we will do, we will add this thing in the current path, and we will return the result. Okay, so this is the answer. Okay, then suppose this is not running. This is not the case. Then what we have to do? We have to traverse left. We have to traverse right. So one we have traverse left. We have traverse right. Okay, then what will happen if we will go for traverse left and traverse right? Suppose we are traversing right. So first thing we will check whether the right node is null or not. It is not null. If it is not null, then we will add it in the our current path because we reached it. We will add it in the current path. After adding it the current path, we will check whether this is the leaf node or not. For that, we have node dot left is equals to null, node dot right is equals to null. This is satisfied in this part, so we will add the whole current path. So this whole path will be added now in the array list, and that's all. This loop work is ended. So this recursion work is ended. So it will close here. Suppose this is not the leaf node, like this in this condition. Then what will happen? It will go in the traverse left, so it will go here, and as soon as it goes here, it will hit this condition that the left node is null, so it will return. Otherwise, and in this part, it will go right, so this will go right, and when it goes right, it will hit this condition again that it is like a leaf node, and we will add it in the add this path in our resultant array. So resultant array list, okay. So that's the whole thing. That's how our dry run works, and we saw that test cases are passing. Now let's see whether our all the cases will pass or not, okay. And it's taking time. Okay, we were able to pass everything. So yeah, 7 ms and all. Okay, this time complexity is one thing because see this current path we are creating now. This current path is a string. Okay, this current path is a string, and string is a immutable type. Okay, immutable in Java. So what happens when whenever we update this string, it creates a new string actually in our memory pool, new string, and then this our current path, this current path keyword will reference to will reference to that string location, not properly like a pointer, but it's a kind of it reference to that string, and our old string will later on will be handled by garbage collector and get removed. So because of this, every time when we update string, we are getting a new string. So it's like it's a kind of every time it is creating a new string for us whenever we update the particular string. So that's why the time complexity here increases, and it takes a little bit of time. Okay, let's just see the time complexity and space complexity once. Okay, so I have notes here for you guys. So see, what we are doing is we are doing depth for search. That's the basic thing. Whenever we want to go in deep of a tree, we do DFS. So yeah, this depth for search is like itself, it will take O of n because number of nodes it has to travel every single node. Here we traveled every single node. That's O of n for sure. Okay, and then we are doing string concatenation also, and as I told, string is immutable, so concatenation always create a new string. So this will give you O of h. So what is the height of the string? Here height of the string is 3. So it will give that O of h is the maximum worst complexity. So suppose it is a proper tree, perfect tree. So every node, every leaf node will be in the lowest level. So on the same level. That's what O of h means. So O of h and O of n, if together they make our time complexity O of n square. Okay, O of n square. But in a balanced binary tree or in a normal case, not in the worst case, we will be in O of n log n. Okay, that was a time complexity. Space complexity, you can read this. It is very easy. Do it as your homework. I don't think so. I have to like tease the space complexity in this video, as the video is already getting long, maybe 90 minutes crossed. So for now, I can just say that we are storing in a result storage. That's a thing, and we are also using recursion. So there will be a thing called recursion stack. You can calculate that too. So that will be your homework. Hope so you enjoyed the video, and I just want to keep it very simple, and it is like how you should do in your interview. This is how you should represent. Thank you.